Hello and welcome back to my channel. Today we're diving into something that might look scary at first, but trust me, it's actually really fun once you get it. We're talking about logarithms and the 8 important laws you need to know to master them. Grab a pen, a notebook, and let's crush this. Alright, first up, what even is a logarithm? The logarithm of any number to a given base is the index or power to which the base must be raised so that it is equal to that number. It is just the reverse of an index. For example, the logarithm of 8 in base 2 is just simply me saying, to what power will I raise 2 such that it will give me 8? That is just the meaning of logarithm of 8 in base 2. It means to what power will I raise 2 such that it will give me 8. In this case, we know that if I do 2 multiplied by 2 multiplied by 2 equal to 8, that is 2 raised to power 3 is 8. It means that the logarithm of 8 in base 2 is just simply 3. Note, 2 is the base, 8 is what we are looking for the log of. So logarithm of 8 in base 2 is 3. How do I know it's 3? Because logarithm is the reverse of an index and 2 raised to power 3 is 8. So therefore, log of 8 in base 2 is 3. Let's take another example. Logarithm of 100 in base 10 is simply me saying, to what power will I raise 10 such that it will give me 100? I know that if I raise 10 to the power of 2, it will give me 100. It means that logarithm of 100 in base 10 is just simply 2 because 10 raised to the power 2 is 100. Please note, in simple words, a logarithm asks, to what power must I raise the base to get this number? That is just the question that logarithm asks. To what power must I raise the base to get a particular number? Now, why should we even care about logarithm? Logs are super useful. They help us to solve equations where unknown is an exponent. They help us solve equations where unknown is an exponent. Also, they are used in science, they are used in engineering, they are used in finance, and they are also used even in earthquake measurements. Now, let's unlock the secret weapon that is the 8 laws of logarithm. Memorize this and you will be unstoppable. Firstly, the product law. When you multiply inside the log, you can split it into 2 logs and add them. That is, if I have a log and I multiply m times n inside of that log raised to in base b, I can simply split m and n as log m in base b plus log n in base b. For example, if I have log of 72 in base 10, I can write this as log in base 10 of, now we know that 72 can be written as 8 times 9. So I can simply break this as log 8 in base 10 plus log 9 in base 10. That's just what the product law means. Next, the quotient law. Division inside the log, break it into a subtraction. Just like product, for division, if I have a division inside of a log, I can break it into subtractions. That is, I can break the 2 logs and subtract them. Let's take an example. If I have log of 0.3 in base 10, this can be rewritten as, you agree with me that this can be written as log of, now 0.3, I can rewrite it as 3 over 10 in base 10, which can also be written as log in base 10 of 3 minus log in base 10 of 10. So I have broken 3 over 10 into log 3 in base 10 minus log 10 in base 10. The third law, which is the identity law. The logarithm of any number to its own base is equal to 1. That is, if I have log of b in base b, it is 1. That is, if I have log of a number and the base is also the same number, it is simply equal to 1. For example, log of 10 in base 10. Because the log of 10 and the base is simply the same thing, my answer will simply be equal to 1. Now, take note of this law because they are going to be helpful when solving questions. The next law is the power law. And the power law says that when a logarithm is raised to a certain power, the power is used to multiply the logarithm itself. When a logarithm is raised to a certain power, the power is used to multiply the logarithm itself. For example, if I have log of m raised to the power k in base k, now because the m is raised to a power that is k, I will use that k to multiply the logarithm itself. Let's take an example. If I have log of 10 in base 10 raised to the power of 3. Now, because I have a power 3 here, I can write this as 3 multiplied by log of 10 in base 10. And we previously talked about log of a number that is the same as the base. So I can rewrite log of 10 in base 10 as 3 multiplied by 1. Log of a number of the same base is equal to 1. So 3 times 1 is just 3. So I have completely simplified log of 10 raised to the power 3 in base 10 as 3. Let's take another law, the power of the base. When it is the base that's power, the reciprocal of this power is used to multiply the logarithm itself. When it is the base that is powered, the reciprocal of this power is used to multiply the logarithm itself. For example, if I have log of m in base k raised to the power in base b raised to the power k, now it is the base that is powered, not the logarithm. It is the base of the logarithm that is powered. Now in this case, we use the reciprocal of k. Don't forget, reciprocal of a number. If I have a whole number, for example 2, the reciprocal of 2 is simply 1 over 2. It's just the reversal of that number. So the reciprocal of 2 is 1 over 2. If I have a fraction in, for example, 2 over 3, the reciprocal of 2 over 3 is 3 over 2. I'm just swapping the numerator and the denominator. That's the reciprocal. That is why the reciprocal of k is simply 1 over k. So we use the reciprocal to multiply the logarithm itself. For example, if I have log of 16 in base 2 raised to the power 3. Now, the base has the power of 3. So if I rewrite this, I will simply have 1 over 3 log 16 in base 2. You know that this can also be written as 1 over 3 log 2. Instead of me writing down base 2, instead of me writing down 16, I can write that as 2 raised to the power of 4, because 2 raised to the power of 4 is 16. And you know we talked about this, that if I have a log that has a power, I can use that power to multiply the base. So I can write this as 1 over 3 multiplied by 4. So I'm using this power to multiply the logarithm itself, log 2 in base 2. What did I do? Firstly, because my base has a power of 3, and we said if a base has a power, we use the reciprocal to multiply the logarithm itself. So I use the reciprocal of 3 is 1 over 3. That is 1 over 3 multiplied by log 16 in base 2. Then 1 over 3 log, instead of me writing down 16, I wrote 2 raised to the power 4 because I'm trying to simplify this. Now, I now have a power for my log, and if you have a power in the previous law, you use the power to multiply the log itself. Now, we simply have 1 times 4 is 4 over 3 multiplied by log that of the same base is 1. So my final answer here will just simply be 4 over 3. So I have simplified this into this. Let's go further. The zero law. The logarithm of 1 to any base is equal to 0. The logarithm of 1, in this case to base b, is equal to 0. The log of 1 to any base will always be equal to 0. For example, log of 1 in base 3 will just be simply equal to 0. That's that law. Let's take a different law. This is the reciprocal law. Now, when the reciprocal of a logarithm is required, the base and the number interchange their position. When the reciprocal of a logarithm is required, the base and the number interchange their position. So, for example, if I have log m in base b, so let's say I'm required to use this m as my base for me to be able to solve a problem. All I just have to do is to write down the reciprocal of this log, which is 1 over the log. But in this case, the number and the base interchanges their position. For example, if I have log 9 in base 5 and I need the reciprocal to solve a problem, I can rewrite this as 1 over, so instead of writing log 9, I should be log 5 in base 9. So the number and the log has interchanged their position. This might be required when solving a problem. Then we also have the change of base. When the base of a logarithm is changed, the initial base is used as a separate logarithm to divide the initial logarithm to the new base. Now, there are cases where you might need to get a new base for your logarithm for you to be able to solve a problem. In such cases, for example, if I have log m in base b, let's say I need a base n to be able to solve a problem. I can rewrite that same log, this time log m, but in the new base, which is n, over the log, the base, the previous base becomes a new log, and what the new base is still n. Let's take an example. If I have log 7 in base 4, let's assume that I want to solve a problem that requires me to use a base 10. So I can say log 7 in this time base 10 divided by, so my new base becomes a log I will use to divide log 4 in base 10. So what have I done? I have changed the base to a base 10. Then the log 7 remains the same. Now the new base is used to form a new log that I'm dividing with. This might be useful when solving a problem. Having gone through all the laws, let's now take examples that require us to apply two or more of these laws. Example 1. Evaluate log 54 in base 6 plus log 2 in base 6 minus log 3 in base 6. How do I go about this problem? We know that if I'm adding up two logs of the same base, I can rewrite this as log 54 multiplied by 2 in base 6. Don't forget our product law. Because the both of them have the same base, I'll simply multiply the log because I can easily break this back to this. Now, log 54 times 2 will simply be log 108 in base 6. We still have subtracted by log 3 in base 6. Now, I can also rewrite this as log 108 divided by 3. Because there is a subtraction in between them, I can divide the two log to form one log. So the two log have been joined together to form one log using my division or my quotient rule. Now, 108 divided by 3 will just simply be log 108 divided by 3 is 36 in base 6. I can further rewrite this as log 6 raised to the power of 2 in base 6 because 36 is the same thing as 6 raised to the power of 2, which can further be written as, so power law says that if I have a power for my log, I can use that power to multiply the log itself, and that will be log 6 in base 6. Now, when you have log of the same base, we simply change this to 1. So log 6 base 6 is the same thing as 1, and 2 times 1 is 2. So I have simply evaluated this question to get 2 as an answer. Let's take another example. Find the value of x, given that log 5 base 10 plus log x plus 2 base 10 minus log x plus 1 base 10 equal to 2. Now, how do we find the value of x here? I'm just going to apply simple laws. The first is I'm going to apply the product law that says that log 5 times x plus 2. So I'm joining these two together to form log 5 times x plus 2. We still have minus log x plus 1 in base 10 equal to 2. So I have just joined these two logarithms together to get this. I can also as well join this. So it becomes log 5x plus 2 divided by x plus 1 all in base 10 equal to 2. So now I have joined all the logs, so the three logs have become just one log. And also remember that I told you that the logarithm of a number is just how many times I need to power the base to get that number. In this case, I can rewrite this as 10 raised to the power of 2 equal to 5 into x plus 2 divided by x plus 1, which can also go further to give us 10 raised to the power of 2 is 100 equal to 5x plus 10 over x plus 1. The easiest thing to do here is to just simply cross multiply. And to do that, we'll end up having 100 times x plus 1 equal to 5x plus 10, which therefore becomes 100x plus 100 equal to 5x plus 10. If I collect my like terms, I'll simply have 100x minus 5x equal to 10 minus 100. I took this to this side and I took this to the other side. So I'll end up having 95x equal to minus 90. If I divide both sides by 95, my x will simply be minus 90 over 95. 5 in 90 will give us 18, and 5 in 95 will give us 19. So the final value for x will simply be minus 18 over 19. So the value for x in this case is minus 18 over 19. So I applied 3 to 4 laws to find the value for x. Let's take another example. Log 10 base 10 minus log 2 log 1 over 5 base 10 minus log 2.5 in base 10. Now, to do this, we need to be able to simplify this by joining them together. And how can I go about this? I can rewrite this as log 10 base 10 minus log 1 over 5 squared base 10 minus log, I can rewrite 2.5 as 25 over 10. So I changed it from a decimal back into a fraction to help me solve easily. If I join these together, I will have log 10 in base 10 minus log 1 over 25, because 1 over 5 squared is 1 over 25 in base 10 minus log 25 over 10 in base 10. If I join this, it simply gives me log 10 divided by 1 over 25 in base 10 minus log 25 over 10 in base 10. Now, do this division, it will be log, so division changes to times, 25 comes up and 1 comes down, minus log 25 over 10 in base 10. 25 times 10 will just simply be log 250 in base 10 minus log 25 over 10 in base 10. Now, I want to join these two logarithms together because their bases are the same. So that would just simply be log 10. Then I'll have 250 divided by 25 over 10, which is the same thing as log 10. Then 250, division changes to times, 10 goes up and 25 comes down. 25 here is 1, 25 here is 10. So we are left with log 10. Log 10 times 10 is 100 in base 10. And we know that log 100 can also be written as log 10 squared in base 10, which is the same thing as 2 log 10 in base 10. And that simply gives us 2 times 1, which is equal to 2. So simplifying this, our final answer will just be 2. Practice time. Alright, kindly pause the video and take some time to answer these practice questions. If you found this video helpful, smash that like button, subscribe if you haven't, and comment the answers to the practice question on the comments below. Stay awesome and I'll see you in the next video.